All right, here we are, part 3, last part of section 8.1. So we saw that we can solve a quadratic equation by using the square root property. The square root property says if we have something of the form something squared equals a number, then that something, equals the square root of the number, or that something equals the opposite of the square root of the number. So when we go to solve something like this, it is not factorable. You can try. And it's also not in this form. In order to use this form, all the variables must be in here. And we must have just a number on the right side of the equation. So this is only numerical. Problem with this guy is we can add or subtract the 4 from both sides, and we get x squared minus 6x equals negative 4. So we have something squared minus 6 times something, and the square root property doesn't accommodate for that. So how can we use this in order to solve this? Well, we need to put this in something squared equals a number form. All right, so ready? This is process by example. So we started with x squared minus 6x plus 4 equals 0. So we're going to isolate the variables, keep the variables on the left, bring constants to the right. So we turn it into x squared minus 6x equals negative 4. So now we're going to do a process called completing the square. Process by example. This is super cool. I think it's really kind of fun. So our goal is to get the right side to be a perfect square trinomial. If you remember, we talked about that way back in chapter 6. A perfect square trinomial is a trinomial whose factors repeat. So we have to strategically find a number that I can add to both sides, because I can add the same number to both sides of the equation and to maintain the balance. We can add any number, but not any number will work in this process. So in order to get this into something squared equals a number form, we need to find, I call it the magic number. And I know it's corny, but to find the magic number, we want the left-hand side to be a perfect square trinomial. All right, so the magic number to add to both sides is found in the following way. We make sure it's in descending order, x squared first and then the x term second. You're going to take half of this number, half of the coefficient in front of x. So half of negative 6 is negative 3. And then you're going to take that number, negative 3, and you're going to square it. Negative 3 squared is 9. This is my magic number for this problem. So I'm going to add 9 to both sides of this equation. I'm going to turn it into x squared minus 6x plus 9 equals negative 4 plus 9. Now, it's super important that you add it to both sides to maintain the balance. So the solution to this equation is the same as the solution to this equation because we didn't change the balance on each side of the equation. Now, what's the point of making it longer on the left side? Well, if we factor this now, if you choose this number correctly, the left side will be a perfect square trinomial. That is, it will factor nicely, and its factors will repeat. What can we multiply to get positive 9 and add to get negative 6? Well, x minus 3 and x minus 3. Negative 4 plus 9 is 5. So x squared minus 6x equals negative 4. translates into x minus 3 times x minus 3 equals 5. We're going to now write this as a square, saying it's the same. X minus 3 squared equals 5. So solving our original problem, x squared minus 6x plus 4 equals 0, is equivalent to solving x minus 3 quantity squared equals 5. Now it's in the form something squared equals a number, and we can solve it. So by the square root property, what's being squared is either equal to the square root of 5, or what's being squared is equal to the opposite of the square root of 5. Treat it as two separate problems. Nicely, we can't simplify the square root of 5, so I'm just going to add 3, keeping the nice part of the number first, and I'm going to write this as 3 plus the square root of 5. And because it's a solution that involves a radical that can't be simplified, I automatically know its other solution. It's going to be its conjugate buddy. Therefore, the solutions are x is equal to 3 plus the square root of 5, 3 minus the square root of 5. Woohoo! Now notice back up here, again, we could add any number. We could add 17 to both sides. We could add 4 to both sides. It's not going to help us. What's going to help us is adding the magic number right here. When we add the magic number, we created a perfect square trinomial. Now, what I'd like you to notice is the number inside the perfect square, in each factor of the perfect square trinomial, is this number right here. When we took half of this before we squared it, that's always going to be the number that shows up inside the factors of the perfect square trinomial. All right, so let's try one more of these. Solve x squared plus 8x. Let's see, I know I'm going to change this number up a bit from my last time I did it. Minus 8 equals 0. All right, now you can try to factor. This is not factorable. So, but it doesn't mean not solvable. Not factorable doesn't mean not solvable. It just means we need to solve it in a different way than factoring. So here we're going to put it into something squared equals a number form, so we can use the square root property. So x squared plus 8x minus 8 equals 0. I'm going to add 8 to both sides, get the x's all by themselves on the left side. Now we have to find the magic number. All right, the magic number we find by taking half of the coefficient in front of x. So half of 8 is 4. And then we square that number. And that's the magic number we're going to add to both sides. So we're going to change this. X squared plus 8x equals 8 is equivalent to x squared plus 8x plus 16 equals, don't forget to add the 16 to both sides to maintain the balance. Now if you choose this number correctly, the left side will always factor and its factors will repeat. What do we multiply to get 16 but add to get 8? Positive 4. So this is x plus 4 times x plus 4. And that equals 24. So we get x plus 4 squared equals 24. Now this is in the perfect form to use the square root property. And the square root property says if something squared equals a number, then that something equals the square root of the number, or that something equals the opposite of the square root of the number. Whoops, sorry, I'm off the page a little bit there. I always solve the positive one first. 24 is 4 times 6. So x plus 4 equals 2 square root of 6. Solve for x. Keep the nice part of the number first, the radical part second. Here we have a solution that involves a radical that we can't simplify. So I automatically know the other solution is going to be its conjugate buddy. Leaving the sign in front of the nice part of the number alone, changing the sign in the middle. So therefore, my solutions x is equal to -4 plus 2 square root of 6, -4 minus 2 square root of 6. And there we go. Let's see, do I have any more for you? I think that's good. Yes, actually, let's do one more here. Just an important little tidbit of information. In order to use the square root property, right, or order to complete the square, your leading coefficient must be 1. So here's an example. 3x squared plus 24x minus 48 equals 0. Leading coefficient must be 1. To complete the square, and use the square root property. So how do we get that leading coefficient to be 1? Well, we simply divide both sides of the equation by the leading coefficient. So 3x squared plus 24x minus 48 equals 0. Divide both sides, the entire left side, the entire right side by 3. X squared plus 8x minus 16 equals 0. And then we would proceed. We would get the constants over on the other side. We would find the magic number by taking half of 8, which is 4. Then we would square the 4. And this is the magic number we would add to both sides. So the important part of this problem is you can finish from here. I will finish it out, but you may not take half of this number, square it, and add it to both sides if the leading coefficient is not 1 here. It just won't work. So x squared plus 8x plus 16. We add 16 to both sides. This is x plus 4. Left side becomes x plus 4 squared equals 32. So now it's of the form something squared equals a number. So now we can use the square root property. X plus 4 is equal to the square root of 32, or x plus 4 is equal to the opposite of the square root of 32. Continuing with this, I need some more paper here. I'm going to do the left side first. X plus 4 is equal to, that's 16 times 2, so 4 square root of 2. Subtract 4. X is equal to -4 plus 4 square root of 2. Radical that can't be simplified. Its conjugate buddy must also be a solution. So therefore, my solutions. X is equal to -4 plus 4 square root of 2, -4 minus 4 square root of 2. All right, to do. So we're going to do this just like we did in class. To do. You are expected to still read in your book. The problems in the book you are responsible for. Exercises 1, 5, 9, 13, 15, 17, 33, 37, 39, 57, 59, 61, and 67. Alex. Now your chapter 8 topics will open after your chapter 7 is done, or after midnight on Wednesday, whatever happens first. So 8.1 topics will constitute about 23% of Alex. I'm not sure yet what's going to be due on April 1st. I'm thinking it's going to be more like 50%. So stay tuned to the next lecture to see what your topics, your percentage goal will be for April 1st. All right, guys, hope you're having fun. Stay safe. See you in a little while.